Hello everyone, my name is Gabriel. Today we are here with the EinScan Libre in order to scan the back of this van. For designing purposes, we are going to use a hybrid alignment mode, which one we are going to use the markers, geometry and features, one of the special capabilities of the EinScan Libre. Right now, my colleague Guido will show you around the scanning process.
Okay, here we're having a scan done with a shining 3D Libre scanner of the interior of a van, and goal is to generate a protective cover for the lower part of this interior. And everything starts with regions which help us to identify geometry much more easy in our scan. And that enables us to select the area for reference geometry generation as it's needed for a first alignment. You can see that we are using removal of outliers in here. That gives us more reliable information. We can also do average planes in between planar areas to identify symmetry planes like shown in here. For the position of the origin in our alignment, it's quite useful to generate a sketch, and we can see in the back part there is a circular geometry that can be sketched as a circle, and that might give us a clue of a meaningful origin later on. So it looks like this is a line in the beginning, but by observing the result of the line generation, you can see that this line doesn't really fit. So it's much more or less a circle, and that circle can be drawn in here by simply selecting the polyline displayed on the screen. Now, obviously, the symmetry line is not available in here right now, so we can step back a little bit, leave the sketch, roll back before the sketch, and generate a vector intersecting plane 1 and plane 2 in here. That would later on enable us to sketch a center line very easily in our sketch. So by rolling to end, sketch is available, and by editing the sketch, we can simply convert this vector into a sketch line and generate a point right at the intersection of the circle and the line. Now, since we have the point available in here right now, line and circle are not needed, so we can delete them right now, which helps us sort out the position of the wanted origin. So next would be the alignment, which is an interactive alignment. In here we are using the XYZ option, where we just have to define the position of the origin and two directions. So z-axis direction would be normal, to plane 1, the bottom plane, and Y direction would be normal to our symmetry plane. This alignment will help us quite a lot in generating our wanted geometry later on. It makes sense to use some standard views to verify if everything has been done correctly in here, which looks quite nice. Then we can also start cleaning up our screen. It doesn't make sense to keep those planes and the sketch on the screen because they have been used for the alignment, and it's better to have a nice and tidy screen in here. Okay, so let's start with some primitive surfaces. You can quite easily generate these surfaces by selecting a region and the surface type. These surfaces are not dumb surfaces, and there's some intelligence in here. You can edit them, you can make them bigger, you can move them around, so we can just edit them to get a more useful layout. Next is the almost freeform looking surface on top of the wheelhouse, and in here you can see that could be done by a sweep quite easily, just containing 2 lines and a fillet. Maybe it's 1 line and 1 arc and a fillet. Just identify the size of the fillet. You can edit the radius to a meaningful number if you like, and of course you can also resize those lines without moving them in here. So this curve, this sketch will be used as a guideline for our surface later on. Now the profile is still missing, but by generating a new sketch on a plane that has to be at the position of the sketch, we can generate this profile quite easily. And in here it's also quite simple because it's just looking like a simple arc. And also this arc can be edited, can be resized to stay in the right position. From here on, it's just a sweep surface function where you just have to select a profile and a path. You can check improve curvature flow. That gives you a nice, smooth and accurate surface. Of course, you can at any given time re-edit your surfaces so they are big enough and suitable for your further workflow. Also in here, just to make sure that you have enough space for the inlay later on, we can edit the position of the guide curves and or profiles. There's another planar surface in there that can be done with surface primitive, plane. Simply accept the result. You can, of course, re-edit the sketch as done before. Just draw it a bit longer. Doesn't matter how much more it will be, because it will be cut later on anyway. And then these surfaces can be trimmed. The result will be a single surface body. If you select too much, you can always re-edit to optimize the wanted outcome. Next would be to add fillets to get a nice smooth connection in between the surfaces, and to adjust the design of our wanted result later on. Now that is looking decent for the moment. Maybe we can extend some surfaces, and here you can see how easy it is to just correct some minor issues in here, and there we go. It's always good to have as less geometry on your screen as possible, so hiding planes or hiding bodies is quite useful to keep an overview over the part you are generating. Next would be entering a sketch the size of our body. Let's say a little bit bigger, because we want to cut the unwanted areas later on. So starting with that already known arc from before, and a rectangle that is bigger as the area needed. We can just replace the right line with the arc by deleting the line and using trim with the option corner trim to close that sketch again. And then you can see that there is some space in between the two seats we have in here. And that can be also added with a little rectangle in here, using Smart Dimension to define the size, and the option trim, power trim, to clean up the sketch later on. And here you can see how valuable an alignment is, because using the right values in here will generate a nice symmetric trim in here. Now this is the option power trim, where you simply move the mouse over the lines you want to delete, and you will get a nice clean sketch again. Next, is the generation of a solid body simply by extruding it with a length that is suitable for our object. So we have to stay below that red region in here. And you can see that our surface body we generated before is cutting through the entire solid body. Now, since we have a symmetrical geometry, it makes sense to make a mirrored object of our cutting surface body using the center plane of our design. Another reason why it's valuable to have a good alignment. And then we can simply cut our solid body using the surface bodies to have a fitting design of our solid. Now in here we can see that there's a little bit more to cut off. So that's also quite useful because you always have the direct message of maybe intersections in there. So generating new objects to cut our solid is quite easy using the same functionality we used before. So using a primitive surface, in this case a plane again, with a preview gives us a good cutting information. And this will be also re-edited, made bigger, so you simply can resize that line. And there you go. Just looking at our solid, we can see that this surface does not cut the entire solid, so we can also extend it, and that gives us a surface cutting the entire solid, and from there on we need a symmetry plane to mirror it to the other side again. And that symmetry plane is of course our XZ plane, or the front plane as it's called in here. And with cutting we can use both of those surfaces to cut our solid at the designed position. Next would be adding some nice fillets in there, just to give it a smooth design. And of course we can add more fillets to our object. Now these fillets can be resized according our needs, and of course also multiple fillets can be added to one single object. So all these geometries were now more or less defined by the scan, but there's more to reverse engineering than just following the scan. You can also add your own ideas to the object you're reverse engineering, because there's also engineering in reverse engineering. So in here I've decided to add a new sketch plane by revolving a plane through the center line of the lower cylindrical surface. And the nice thing is that you can revolve this plane by a defined angle, so you get some reasonable new designs. And in here, just as an example, two new angles are cut in our solid later on. It's a simple design that is not based on the sketch itself, but on an idea to have some new geometry on the final result. You can add dimensions in there, define them as you like. Of course, also same with the fillets. After all that is done, you can also reposition, change all that geometry. And with Control, you can also make a copy of that sketch element using Extrude to make a new surface in here. And of course you can mirror these surfaces using our symmetry plane again to the other side, so we have a symmetrical outcome, which is the desired content in here. So here I simply switched the surfaces to a volumetric part, because then we can use Boolean cut to cut out all these bodies out of our center solid body. So we have something like that, reinforcing edges in here, adding some fillets, just to have a smoother design. And well, this is almost everything that needs to be done, except we have to hollow that part. So generator shell is quite easy by defining the depth, the thickness of the part, defining the basic body and the faces to be removed. And this is protective shell for our part that helps us to keep our van clean and tidy.